Cheers.
Nathan, that's so good.
This is from Central California, Paso Robles.
Oh, Paso Robles, yeah. My girlfriend is actually grew up in Los Olivos, so we went to Paso Robles a few years ago, and it was amazing.
Awesome.
Nice.
This is called, it's currently midnight, is the winery. And
Cheers.
it's an unfiltered, it's a bit of a mix of everything called a condensa.
Oh, okay. Wonderful.
Yeah, unfiltered.
Can you guys talk so I can see if I can hear you? Can you guys hear me? Can I hear you?
Jimmy.
Everybody hear everybody?
Hello?
Yep. Can you hear us?
We can hear you.
Is it too loud?
Excellent.
Loud for me, actually.
We can kind of see you.
Are
Sounds good.
you ready to roll, or is there any tech?
I think we're good.
Good? Okay, awesome. Spiro Michalakis, welcome back. Welcome back to the world of flat
Good to be
Earth.
back.
We're so happy to have you back. And I
Thanks
just want to
for having me.
review for anybody watching for the first time. This is a quantum physicist who works at Caltech. He does outreach for Caltech for science. I'm going to hopefully get this mostly right. And you do many other things. You solved a problem that Nobel Prize winners failed to solve.
Yeah.
You are extremely well known, especially in the science world. And you have you do consulting for movies, for big Hollywood movies, for explaining the physics of superheroes and such. Maybe that's not accurate. Something like that.
That is actually very accurate.
Is that very accurate?
I will
Okay,
hire you to open up for me in my
very
future
awesome.
talks.
I
You know?
could use a
Yeah.
sidekick. Okay, and you have spoken a little bit about flat earthers. You spoke in the documentary Behind the Curve, which is where I met you at that screening. You've also written an article, and you have sat down with us for over 2 hours and listened and talked and had a conversation about flat Earth, which I like to think of as somewhere between a peace summit and just a casual hangout.
It was actually a lot of fun. That's why I was open to coming back, right?
That was
Plus
awesome.
the wine. So.
Well, that's what I was. So, can I ask you, how was your first week of life after you hung out with flat earthers for the first time?
It was actually even better than I expected.
Yeah.
Right? I mean, but think about it, right? This way, when you meet good people from any walk of life, you make new friends, right? It's just, it's a bonus that it happened under such circumstances. I did go back and tell a couple of my friends, like, I had a really nice evening. And I was, if I didn't have plans for dinners, I wanted to actually stay and get, some dinner, drinks and stuff like that. And I want to put it out there as this way that, I know you feel that the rest of the world sees you as flat earthers as something like negative and whatnot. And you've been through a lot. And it's funny, the irony of it being like scientists also went through a lot back in the day of the Inquisition and so on and so forth. It's always like that, right? When you're breaking new ground or trying to understand, go deep, you're skeptical, curious. And I really respect and appreciate that. But, as I said also in the article for McLean's, right? I want to know your story. It's not just about the theory, because we can sit down, right, and talk for hours about the theory and try to prove to each other whether we are right or wrong. But I was thinking, even on the way here, what is the most interesting thing about any group of people who are curious and are coming together, right, to figure something out, is not the result. It is the journey, right? I was thinking about the research you've been doing. Okay, what if I were to tell you that, oh, you don't need to do this research. The answer is already known, right? The world is a globe. Or worse, someone from the flat Earth community comes to you and says, no, we don't need to do this research, right? We already know the Earth is flat because we know that the other people are telling us lies, right? Well, how would you feel? You've gone out there, you've done the hard work. You had to design the thing, take responsibility for what you find, right? For refining it, for like figuring out what it all means. And they haven't, right? And you would be like, no, in either case, you would want to be, you go out there with me and let's do this, right? And I think that's what unifies us. The journey, the fact that there are a few people that actually go out there and go through the shit of like, figuring out how things work and seeing it for themselves, right? And having doubts and figuring out like, where do they fit in the community? Are they mavericks? Are they, whether you're like in politics, right? We had the Kavanaugh hearings and all these issues, and Lisa McCorsky, right? Someone who is from the, Republican side, right? Went off and said, nope, I can't vote. And then Donald Trump comes out, is like, I will make your life a living hell, right? And so on and so forth. I believe the people that I respect the most are the ones that take responsibility for their actions and their words, and they live their truth, right? I think that's very important, that you go through it. And I said last time, that one of the things that I don't appreciate about the Flat Earth movement is this distrust of others, right? I was, wanted to be honest because I really like you guys, okay? And this is something that I think unifies your community, which is a good thing, but it can also be a negative thing. And
we're just skeptical.
Yes, yes.
Not distrusting.
Yes,
Distrusting.
and there can be others that are more distrusting, less distrusting, skeptical, right? Scientists are skeptical. And I was describing, the Flat Earth community from my perspective to a good friend of mine, a scientist. And I said, like, they are super scientists. They're more scientific,
That's so nice of you. That's
than like
what we wanted. Was
no,
for
but
you
that's
to see that
but I want to clarify that, right? You're super scientists, which means that you're just like the original scientists, very skeptical, right? Whether it was originally the church that was telling us the earth is like this, or we're at the center, or like this is like, how you have to live as a woman or as a man, or this is what is right and what is wrong. There's some people that were feeling like, but where is this coming from? Where is that authority? And is it okay for the authority to like, to tell us all these things, for us to say, yes, whatever you say, you know better, you're a king, you're a sun god, whatever it is, back then. Super skeptical, right? Which is a big aspect of the scientific community, the super scientists from that point of view. But one of the things that, and I just said that worries me about the community is that this skepticism is in a reaction, at least in my mind, and maybe I'm wrong about this, to the findings or whatever of a perceived enemy, right? So maybe I'm wrong about this, and you can tell me, right?
We can discuss
exactly, and I think that's an important
yeah.
part to discuss, because what can happen is that you can be hyper skeptical of an idea, right? Because you feel like, for whatever reason, maybe intellectually this doesn't make sense to me, or you really don't like the other person and you don't want them to be right? And then you become hyper scientific, but to the point where you go to the opposite. And the opposite idea from that person's idea or that group's idea has to be true. So you put all of your effort into showing, through scientific methods or whatever way you can find, that this is the right view. Not like in openness, maybe they're right, or maybe it's not, neither point of view is right. Maybe, I heard last time, it doesn't have to be even flat. Maybe it's hyperbolic, maybe it's something else. It's just not like this, right? And this is like something I would like to discuss, Could it be that through your super scientific mind, you end up figuring out the best way to show that the earth is actually round? Right? Would it be something, that'd be pretty cool too, because so far you have to have millions of those out in space potentially to, for yourself, or to send one of those little experiments that they do with a GoPro up, and then maybe you see curvature, or maybe you don't, whatever it is. What would it feel like, right, for either side to be, oh, wow, it is flat, or, oh my God, I see the curvature. Are we ready to accept what will happen, right?
It would be incredible. It would be so empowering if we could prove the shape of the world without NASA, and because not just out of distrust, but because we can't participate in NASA. So from our stance, it's not scientific to believe NASA, because we can't repeat that experiment they're doing. And we would need to test and repeat and test against. And since we can't go up in a spaceship, it's just a belief system. And so it would be incredible to explore with scientists, with everybody, with our, we identify as scientists also, super scientists, but for all of us to be able to know how to prove it on the ground. And I think it's possible. And I just want to, I think that it is something of a misconception that we want it to be flat. And I know it may look like that from the outside, like from the way that we get represented in the media. Or even
Oh, yes, I can assure you, we do not prefer it to be flat. Like, nobody wants to be part of everybody thinks you're crazy club.
Yeah.
It's not fun.
That's that. It's like, you just want to know what it is.
Yeah.
Like, there's a lot of people in flat earth who are like, you know what? It's flat for, 60 miles. But then what is it? Because it doesn't seem...
You can't tell, say, with the current experiments, maybe it is not flat after that or whatever.
I mean, we have water to work with. We know that there's so many oceans, and oceans are fairly level, so that's why we're assuming flat, but it's very open for us. We want to know.
Let me ask you something, because you have done experiments, right? Maybe you have done research, right? And I want as honest an answer as possible. This will be like a guilt-free zone. From my side, your side, I hope, and so on and so forth. When you look for research, to do research, right, or for evidence, do you look for evidence that the Earth is a globe, or for evidence and experiments that the Earth is flat? No, but before, like, you have to take some time to think about this, right? Are you looking for evidence that your gut feeling? I mean, as human beings and as scientists, like I've been doing this for a while now, I'm going to be honest, it's always my gut feeling. I want something to be true, and then often I'm wrong, and I find something else is true, the opposite usually of what I was thinking. And you always have this initial feeling of feeling like shit. You feel like you failed, because why was your intuition wrong? Why was and it's not even other people knew what the answer was, right? Say nobody even knew what it was, okay? Maybe nobody had figured out yet what the shape of the Earth is. And you get to this point where it sucks, because you spend all this time hitting your head on a wall for the wrong reasons. If only somebody or you had figured out it was maybe assume that it's not this, it's the other thing, you have been so fast on the right path and figured out the answer. But after this happens, I just want to finish with that, because it has happened to me so many times, right? I realized something insane, that the feeling of figuring out that you were wrong, but somehow with that integrity, right? You pushed forward and tried to figure out what actually happened, because you didn't even know it wasn't like this or that. Maybe there's 10 different scenarios, right? And you figure out one of the 10 scenarios that actually works, is such a euphoric feeling. This is the only reason why I think scientists continue doing science, because no matter how shitty it feels at the time to be denied, when you do figure out and all the puzzle pieces fall together, it's such an incredible feeling. And then you want to share it with the rest of the world. And I know you feel like
I
the
was
same way,
just
right?
talking with Snack on the panel about that last night. We're talking about what did it feel like to realize it's not a globe? Like, what did it feel like to change our mind from the globe? And Snack can talk for himself, but I remember it felt so good. It felt like letting go. It felt like, it felt like freedom. It felt incredible. And the humility of I could have believed something that I didn't bet all this time felt incredible. Like, honestly, I want the feeling again. I would love to be wrong about flat Earth. I want to discover something new all over again and let go all over again, because it feels so good.
I told you, you're a super scientist from a point of view. I'm not just saying it to be nice, right? Like, I could sense it, that there is an aspect where even scientists like myself, you get tired sometimes. And you're like, you don't want to go any further. I never did an experiment to check whether the Earth was a globe or flat, right? I just, I believed in some of the things I told you last time, and I have faith in people the same way that, I have faith in you as good people.
I think that was our problem too. You should try to check to see if it's flat or a globe yourself, and you might end up sitting with us more often, maybe.
Yeah, no, I'm with you. I get that. But to me, it was something deeper, right? And I said that last week, that it won't make any difference, if we are honest, all of us here, whether the Earth is flat or it is round for our day-to-day lives.
I disagree.
Unless, and that's what I said last time as well, unless what really matters is not whether the Earth is flat, right, or whether it is a globe, that we are talking about a different problem. The problem being, can you trust authority or not? And at what level do you stop trusting? Who do you trust, right? And if that's the case, then the Earth being flat or not is not even, it is described as the biggest conspiracy or the biggest lie or something like that. It doesn't even matter, right? Can you trust authority or others, scientists and others as well, about anything? About whether your water is clean, about whether like there are unicorns and they're hiding them everywhere.
Whenever I hear that, I kind of want to turn it around. Like, why doesn't the government trust the populace? Like, why did they think that we're out to destroy them, or out to be bad people, or out to destroy democracy?
The government doesn't seem to trust us very much, but they want us to trust them implicitly.
No, sorry. I mean, like, who in government?
People who come on the media.
Well, we have a lot of laws. Lots.
Yes.
Millions
yes.
of laws.
More being
to keep us controlled. For what reason? They don't trust. Somebody obviously doesn't trust me to be a good citizen.
I agree, but we made these laws.
I didn't make.
We didn't make these laws.
We did. I know it sounds
we
like we
didn't
didn't, and like we could have representative democracy versus directly go and click online and be like, no, I don't want this law, right? And I agree that would be great if we can do it, and maybe one day we will be. But the people that, maybe these big corporations and so forth, wear your seatbelt, or like don't, drink tainted milk or whatever. But then there's the other more insidious potentially laws, right? Where you feel like, why do I have to, they baby me about everything? I think it's much more banal than that. I mean, there is, of course, parts, right? There is money, there is interest we don't even know about, right? And there is assholes out there. I mean, even when it came to smoking in the smoking campaign back in Philip Morris, 50 years ago, like, no, cigarettes are great for you. Have you do smoke more? Like, it's great.
Doctors like camels.
Yeah.
Yeah.
But this is, I mean,
but
that's what it comes down to, though, right? That you don't, like, who do you trust? But as I said last week, to me, I can trust people like you, even though we have completely opposing views, because as human beings, we can see eye to eye, right? We have much more in common than we have superficially different stuff, right? But I feel the same way, like I need to give the same benefit to my other friends who work at JPL and who've never been up in space either, right?
My friend Lady Onyx says, I wish you would stop being so charming.
Oh my God.
So
It's the wine.
I'd like to answer your question.
Yes.
The experiment and what do I expect going out and doing experiments. So for me, what I expect when I go out and do an experiment is to observe whatever is going on right in front of me. I don't go out expecting, now do I have, my motivation for doing the experiment was to prove at least something, just to show what we're seeing.
It's okay even if you say that to prove that it's possible to see something that you shouldn't be able to see if it was curved.
Exactly, to prove that I can see beyond the 3 mile horizon. My motivation is to see what's there. It's not to put any kind of spin on it. If there's something there, I want to see it, and that's the motivation for my experiment. Yes. So and also to address the trust issue. We say we don't trust. Like I said last time, I don't trust anybody. But I meant to clarify that there's a level of trust. I would trust you to hang on to my wallet. I would trust you to.
Wow.
Yeah, I mean,
that's amazing.
I know your name.
That's right.
You're a little naive. He doesn't.
Yeah. It's an empty wallet, so I get it.
I mean, I would trust the guy down the street to give me directions to 7-Eleven. I trust my mom to
raise
give her honest opinion of what she thinks of my hair and my beard.
Yeah.
What I don't trust people. Where the trust stops is where somebody tells me what I have to believe.
Oh, sure.
When somebody tells me that my cognitive reasoning is inept and I'm not capable of understanding something.
Let me ask something though on that. Yes.
We got a new member on the panel here. I want to introduce who's here anyway. We have Karen B. We have Poncho.
Hi, Poncho.
We have Josh.
Hi, Spiros.
Long time no see.
And we have Chibi and Snack. All right. Everybody say hi.
Those are cool names.
Hello. Hello.
I'm a Jedi, though, so I'm kind of on your side in a way. But, I'm a Jedi who works on a flat Earth. So
That sounds cool.
It's a whole new realm.
Karen.
Hi, Karen.
Where's Karen? Where do you live, Karen?
I am in North Carolina.
North Carolina.
Mm-hmm.
Good place.
Yeah, I like it.
I think it's important to point out, like as a flat earther, the vast majority of us, in fact, I don't know anyone who hasn't. We have all grown up believing the heliocentric model.
Yeah.
Like I love Star Wars. Like I watched, all the space shuttle, all the space shuttle takeoffs. Like, so there was no like inherent distrust in any of these institutions at all. I think for most of us, for the majority of our lives. And when I was initially like introduced to flat Earth information and information that did contradict what I thought I knew, what I thought I knew my entire life, that's not an easy process. It does take a lot of humility, like Sasha says, to actually take a step back and just simply say, wait a minute, could I have been wrong?
Yeah.
You know what I mean? So flat earthers have all gone through that. Like we've really gone through it. Yeah. And one of the first steps, like you mentioned in the last talk, one of the first steps, or you said, why don't you reverse it and try to prove the globe?
Yeah.
That is absolutely what every one of us does from day one. The first time that we hear any of that information, of course, like there's so much evidence for the globe. There's pictures, there's NASA, there's all these different things. Like that's what we all set out to do.
Yeah.
And then we are presented with a reality that contradicts that. And you go down every single one of those avenues, and hopefully that's kind of the journey that we're going to take you on today is kind of our process and how we came to change that, and I think a lot of us didn't want to. Like there's no benefit, there's no financial benefit, there's no social benefit, there's absolutely no personal benefit to saying you're a flat earther in any aspect.
I mean, it's getting a little cool.
Well, yeah, now. Well, I mean,
it is like the hip thing.
But this was like 3
It wasn't 3 years ago.
Yeah, exactly.
When I first watched a video that made me first ask a question, it was a short video, like 10 minutes maybe. My first response was I Googled the history of the globe, and I found like a 60-page PDF about the history of the belief in the globe. And I realized I had never researched that. I knew a globe, but I never, and I read it, and I thought about it. I thought about what I was reading, and I was like, when was the time when we tested against it? Mm-hmm. We have this story that everybody thought it was flat, and then we circumnavigated, and we saw some shadows, and then we're like, all right, globe, we're smarter now. But I was like, did we test against that? Did we consider other possibilities of what those experiments could indicate? Mm-hmm. There's a lot. I mean, you take those shadows experiments, there's a counter explanation with the flat earth. It's very strong. And
so let me ask something on that, because again, I want to make this clear from the beginning, right? That I believe that the Earth is a globe. I know we've discussed this already, and I not just because I trust people. That, there you go.
Team Glove. We respect that.
But the reason why, right? I have many reasons to believe that, from ancient times to recent times and all that stuff. But the one thing I want to ask is the following, and this is a procedural question, because in science, what happens is we always try to also see both sides, right? And actually, sometimes it's harder because there's not just 2 sides, there's 7 sides, and you have to figure out like which side, right, you're on relative to all the other ones. So when you read all these articles, pro globe and against globe, the ones that say, well, but have you considered it this way, right? You could explain it this way. Do you ever feel that the explanations that come from the flat Earth side are as elegant, or are they more elegant, or are they more complex? And I want to preface this with the idea that, I don't know, whenever the Copernicus and Galileo were around during those cool times, they had the idea also that the Earth was the center, right, back then. And then everything else was moving around, and I mentioned it last week as well. And they made for a beautiful but super complicated model of epicycles, of things moving around, and the mathematics of it, and trying to predict the movement of planets and all these things, right, around the Earth. And then the moment that they put, like, the sun in the middle, all of a sudden it was just like, oh, okay, that's dumb, that's easy. All right, everything is just moving in these simple elliptical orbits around the center, right? So, yes, please.
Pretty good, right?
Oh, it's amazing. So there is another aspect, right? You can always fit the data to a hypothesis, and there is, by the way, an extreme hypothesis, which is, we call it in science the God hypothesis, right? That everything works, no matter how complex, and somebody can figure out how that works, but that someone is God, right? So that could be cool, but there is a problem with that. It gives you almost no information because you lose complete control. That's the ultimate authority, right? Where you cannot never say no.
Surrender.
Exactly. You're like, you don't understand something. It's the sun. It's the thing. It's an abstract God, right? A father figure. And what if there is a simpler explanation? This is called Occam's razor. It doesn't always have to be right, okay? It's just a heuristic. But it says that if you can fit the data with a simpler model than some other one, you should pay attention to that model. Why? Because you're making fewer assumptions, right? Which means that it is an even more powerful and general model where it's not just fitting the data. We are actually having exactly that problem with what is called machine learning and artificial intelligence right now. You throw all these Google resources to try to understand, like, what the pattern is from all the billions and billions of gigabytes, right, of data, so that you can predict, right, if what your car sees is a car or a cat or a human, and you can classify them differently. And the problem is that these models, these computers, are creating a theory of the universe around them, but often they overfit the data. So they become really, really good at predicting the model for just the data they've seen, but they're useless the moment that they see a new piece of data. Because they're like, yeah, how do we explain this one? And they have to change their theory in many different parts and say, like, hey, how do we do this now? How do we explain this? In the Bible, there is like a small segment where it talks about the circumference of a circle relative to its radius, right? And it says it's 3. The ratio is 3, right? It's not 3, it's 3.1415, right? It's pi. It's close enough, it's 3, right? But this comes from God. So how the heck are you going to go against God's version of, pi? Pi is 3. That'd be cool, it'd be much simpler to remember, but it's not, right? So you have to come up with all these other, no, but it was interpreted in such a way, it was an approximation, it's this and that, instead of just saying, like, well, maybe that was just some human being just measuring quickly what was going on around and be like, yeah, it's 3. It's about 3.
I remember thinking early on, because there is an exquisite explanation for what we observe. Like the Copernican model, when NASA's telling us, it's exquisite, and people spend their whole life studying it and knowing it.
And it's actually useful too, right? We've been.
I
mean, if you, like me, you believe that we have gone to the Mars and all that stuff, like, it has helped a lot with the math and the astrophysics and whatever. But again,
I bring it down to something very simple that won't cover all that. But what I thought of was, in ancient times, actually in Greece, my knowledge, I used to love Greek mythology. I remembered that. They explained thunderbolts was Zeus was angry.
Zeus was farting thunderbolts.
So if we lived in that time and we saw thunderbolts and we had this exploit, this story that this was the emotion of the God, King God, and if you were like, well, I think maybe there's another reason for thunderbolts. I don't even really know what it is. Yeah. But I'm questioning it, and somebody would be like, what's wrong with the Zeus story? Doesn't that make sense to you? Yeah. And it's like, I don't know how to replace it with something as beautiful, but I am questioning it, and I think I have good reason to question it. And so, I think that's where
as far as Occam's razor, as we're going to talk about simplicity, flat Earth is Occam's razor's best friend. We want to talk about why do we not see curvature? Because it's not there. It's simple. Sure. How come we don't feel spinning 1,024 miles per hour? Because we're not spinning. How come we don't observe any of this evidence? And it's plain and simple because the reality that we observe. To go into the heliocentric model, why don't we feel we're spinning? Oh, well, there's this theory of relativity, special and general, which we're not going to feel anything moving because we're moving and everything else is moving, so we're not going to see any movement. Everything's relative. Yeah. we don't see any curvature because we're too close to the ground, so you have to get really high up to see it, and none of us can get that high. So, all these elaborate explanations to explain why we don't see what we're told to believe. And that does not line up with Occam's razor. The simplest explanation, the reason I'm seeing, this light from 10 miles away is because there's no curvature. It's simple. It's very simple. And the elegance is used against us. People use big words, they use fancy words, they use math equations, and it's almost used as a weapon for simple-minded people. And that's what the appeal, I think, the major appeal of flat Earth to most regular people is that it's something tangible, it's something you can see, it's something you can observe, it's something that you can feel.
So when I said that you guys are like super scientists, I meant it, right? And anyone who thinks of you as simple-minded, because yes, I'll be honest, like, when I tell them that I'm coming to talk to you, right? They're like, oh my God, are you serious? I'm like, yes, I'm serious. These are really great people. I have a lot of fun. Like, I'll go back again and again. And they're like, but they're crazy. And this is obviously wrong and all that stuff. And I agree with their second statement that this is obviously wrong. But I completely disagree that you're crazy. You're as crazy as they are.
They're missing information, basically, getting to know us.
Sure, yeah. But I don't even, honestly, at this point, I think what is interesting to me, right, and it keeps coming back to me like this, is that what you said, right, that there's a simple explanation. We see the data, right, this is the best way to explain it, and then there's like convoluted, you have to go high enough, you have to see the curvature and so on and so forth. To me, there is another possibility, right, that the universe is much richer, much richer than even the possibility that a planet is not flat and it is like a globe. Much crazier. I alluded to some of that last week, but I'm not even talking about like, this is so, like, to me, such simple things, right? Even to consider an Earth that is like a double donut, that the fact that space and time don't even exist and they're illusions, the idea of what is even flat, where does the concept of flat come from? It's a concept of geometry, right? From ancient times, and more recently, like say 150 years ago, 200 years ago, German mathematicians and others exploring geometries that were not flat, where you have like locally flat, curvature, but globally there's a different way, as I was saying, of patching these local patches together to get what is called a big atlas. But sometimes it's flat, sometimes it looks like a horse, whatever, a saddle, right? Saddle. And other times it looks like a sphere, something with positive curvature where it comes back and meets itself, right? Kind of like say. So to me, the fact that it is possible to have much more richness and complexity than what we thought from our local point of view, where you say like, yeah, we all agree, right? Everything is flat. Look, right, from our point of view, this is what's going on, okay? If you throw light and you can see it from 10 miles away, how the hell would it be curved? It would be too low, right? Even if you do the math, there's something else. What if, and this is where science gets cool, right? What if there is an explanation, and you're right, it is more complex, but it also explains a bunch of other stuff that without this more complex explanation, the original explanation would have to be 10 times more complex.
So scientists and flat Earth should work together to figure out, and you can ask Caltech to bring all the resources to help us figure out the true shape.
All the resources.
We want to know the true shape of the world. We don't care if we're wrong.
No, but okay, so I'm going to ask you, like, there was a question?
Oh. Last week you asked, what would it take for us to come back to the globe?
Yes.
First of all,
a party. A great party.
To the ISS.
Yes.
And she says,
no, yes.
She says
I was considering, it's expensive. No, but let me ask you something. Yes.
I want 4 cameras on a rocket. Take the trip to the ISS.
You are reading my mind.
No edit.
You're reading my mind.
CGI,
You're reading my mind.
No CGI.
I can do that for you.
You can?
Of course I can do that for you. It's something that the two of us could do together. Actually, all of us can do.
Love it.
It's actually very simple, and it's not going to be a NASA rocket because we don't trust them anyways, right? But you can create your own balloon that can go and that you can see your own camera, right? And you can keep track of it. Yeah. And it goes. I mean, we don't even have to go to the ISS. You just want the first time. But say that, I
So
mean,
what are we talking about?
we're talking about like just getting a little of these balloons, right? Where they do their, citizen science satellites, where these kids in high school send their stuff out and they put a little GoPro.
But we already have high altitude balloon footage that goes up to 121,000 feet without a distorted lens, and it shows a flat horizon. Where NASA says we should be seeing a curve at 65,000 feet, we go double that and we see a flat horizon. So we already have that footage.
Like, right?
He's gonna try to bring it up.
Yeah, if you want I don't have the balloon footage. I have pictures from 120,000
Yeah.
feet. What are you talking about?
Oh my God, we want to work with you guys.
You can just look it up on YouTube. It's under dog cam. The dog cam high altitude balloon footage.
No, you can say yes or no, but everything you're seeing here, we want to take you on like a safari of some
feet,
flat evidence.
Yes.
120,000 feet.
Neil deGrasse Tyson says we should see curvature at 75,000.
Yes. So this is from
120,000 feet.
So who took this picture?
This, I believe, from the dog cam.
Yeah, there was
dog cam. Is the dog cam up there right now?
No, it blew up.
Okay.
It came back.
That's great.
Two elementary
I would want us. Okay, that's great.
We have the whole.
I would want us.
again.
No, I'm saying like we should do this.
Yes.
I'm signing up like with you because
Yes,
it'd be really
that's
cool
what
to
we
do.
want.
And then we figure out how to do this. And I don't know what we're gonna see, right?
We
And
don't
it's
know
gonna go
either.
up. Maybe it'll explode or implode if it goes up into empty space or whatever. But what we see is what we see, and we tell the world. I will tell the world. You can tell the world, right?
This is like our dream. Like people are like, "What's your goal meeting with Spiros?"
Yes.
I got an
And I was
easier
like, "We
one.
want to collaborate."
Well, it might not be easier, but it's easy enough.
We send a monkey to
We
space.
get a plane that can fly around the world, north to south.
Okay.
4 cameras, just fly around,
Yeah.
24-hour flight.
Live feed.
It's live feed. Just go around north-south at, I don't know,
Are you aware?
60,000 feet.
Are you aware
Yeah.
that people don't cross Antarctica? That we only circumnavigate east to west or west to east? That we don't have record of somebody circumnavigating north to south and going.
I think you saw in the
under
documentary of
Antarctica.
somebody showing, right, like where you saw a bunch of flights actually going through.
Well, that they're not going through.
The flight tracker?
They're just.
I mean, it's
they're
close,
in the
but they're
southern
not-
hemisphere.
No fly zone.
Usually, like there is.
Where's this flight?
I think there. By the way, the reason for that, right, as far as I understand, is that why the heck would you go like unless you're going there? And I know people who have gone there, come back in other
Do you know
places.
people have crossed Antarctica?
Yes, I mean I know. Well, I know people that have gone like to Antarctica for research and then
Yeah.
come out, say like to the other side, Japan. Say
If you
whatnot.
can prove that to us, you will bust
Really?
open the flat Earth movement.
Okay, I mean I don't want to bust open anything, but these are like.
Did they go like really inland, or were they just stationed along the coastline?
Heard it, or did they truly?
No. I mean, wherever they were stationed, they have little like scientific stations back on the north and on the south, and of course, right. And it's a terrible thing to live there for 6 months, but they do it, and then they come up. One of them is a good friend of mine who now is was not working for JPL, and now went back. He's like, wow, this is amazing. I want to do more like research there. And JPL goes to space. She went like to Antarctica, right, just to to take samples and stuff like that. And then she came back like she did because she was like, I'm never going to do this again. So she did like a circumnavigation where she went to Japan, then came like India, then like Europe, and then came back. And all
We
stuff.
would freaking love to see that evidence because we often say like nobody's doing this. If you can prove
Let's
that you
get
can
an
do
Well,
it.
let me ask you something. Actually, I just got an idea.
Jet.
I just got an idea.
Let's just
I just got an
fly.
idea. Let me ask you something. I just made it up in my head.
Let's
Right?
go. Let's hear it.
Why is the North and South Pole frozen?
Well, the
Well, the
North-
North Pole's not frozen all the time. The South.
No, sure, yeah, because say
Antarctica
we
is
could,
always frozen. So
So what is going on?
Kenny,
How do you explain
Can
it?
you bring
If
up
it is
a
flat,
model of the
where
sun
exactly is it?
moving around the
And where's the
flat
sun?
model?
So the working model is
I don't
Antarctica
know.
is an ice wall, like a circular ice wall. that
Just like
that contains,
Game of Thrones.
Yeah, that contains the oceans. The oceans say basically picture a dinner plate
Hold on.
Okay.
with the North Pole.
But if the
in
sun is
middle.
above anywhere, it will melt that
Well,
no matter what,
it'll
right?
melt.
Unless it's on the other side of the
It's
earth.
close.
Okay, so
If the sun is close and small,
Oh, take a look at this first. It's so awesome.
Yeah.
yeah, the
Okay.
So, Kenny, you want to explain what that is?
That is the jet stream on a globe versus this is called a
Oh.
this is a null school.
Yeah, I'm seeing something.
Null school map.
Okay.
It used to be online. They took it off.
You just flatten it.
Because we were talking about it 2 minutes.
It's the azimuthal equidistant projection, is what it is.
Yeah.
Yeah. So basically, the
Makes
sun,
you realize how big Africa is.
the sun.
Yes,
throughout the
right?
year,
African should be bigger than it is on a globe.
We know, but it's just hard to.
But it fits on a flat Earth.
Throughout the year, the
That
sun.
jet stream's a little kooky on the globe, man. It's really predictable on the.
Look how
Talk
natural
about
that was.
simplicity.
Talk about Occam razor. Look how natural.
Okay, because even on a flat Earth map, the sun still does stay between the tropics. It stays between the Tropic of Cancer and the Tropic of Tropic of Capricorn, excuse me, which is in the center. So the sun still stays between those tropics. They're just placed in the center. It's like a donut shape.
Let me, because I know so little about the flat Earth theory. Like a quick question: is the sun also flat?
No, we don't know.
We don't know.
But
Okay.
The Egyptians called the sun a disk. We'll say that.
Sure. I mean, it looks like a disc.
It's a
really.
circular,
Right.
it's a circular energy
Good.
source in the
Does
sky.
not look around. There's no.
But it's like, of course, nothing looks right. You know, when you're looking from far away, you look at a projection,
circular
right?
Object from any high altitude will look.
Yeah, like a disc or something.
We don't-
I've actually spent a lot of time observing the sun, and I don't believe that the sun is flat. It does appear to be spherical to me because whenever sunspots appear on the outer edge, you see them at an angle when they start, and as they move in towards the center of the sun, then they change shape, and you seem to see a different perspective of it. So
But I have a question.
I say no, that the sun is not flat.
Like, why are there spots on Earth, on the flat Earth, right? Why they're on the center or like towards the outer walls, where the sun's rays somehow don't hit, but they hit everywhere else in between.
So
Like, because, right, we do agree that, you know, if the sun rays are coming, they're coming uniformly, and like there's no special place on Earth. It's like, oh, I'm not getting any sun for some reason.
Well, yeah, in the heliocentric model, the sun is 93 million miles away. So that the sun being that far away, the sun rays are said to be hitting the Earth in a parallel, right? But in a flat Earth model, the sun is small and close. It's actually considered to be the same size as the moon.
And that's why we get crepuscular rays.
Right.
Oh,
So it's a small local light.
Rays that come
Actually,
out.
I'll show you what they look like.
okay.
like when you see a street light shining down, with
Yeah.
the rays,
Yeah.
Yeah.
source light,
And-
that's a crepuscular. So when we see in the cloud,
Yeah.
the cloud is
Usually
blocking the sun, and you
it's
see a little
fusion.
hole in the cloud, and the sun's
Yeah.
shining through it. You see crepuscular rays.
And as it circles, it carries the daylight with it.
Just above the clouds, and that's what makes us believe.
So you're
that-
saying that like the sun is so close
Yeah.
that it doesn't like as it's well, but this is
There's
also a
a
problem
picture of
because
the-
it does.
I mean, there's a counter argument
Oh, sure.
that people say it's just the clouds. It's just.
Oh no, it is the clouds.
And
I
that's
mean,
a
yeah, and there's
possibility.
points in the clouds where you have openness and others where you don't. Otherwise, when there are no clouds, right, you don't see any of that, and that's the reason.
You do if you take your hose and go outside.
Oh yeah, that's because like
The
again,
water
there
vapor.
is something that reflects and diffracts like the light, which like the air. You don't know it's there until you go like that, or
But-
like a gust of wind
But
hits you.
what we haven't proven is
A messenger.
that sun rays are straight otherwise.
Well,
we don't
but you
know
need
what
that because otherwise you cannot do any of the experiments, right? You've been talking about. If light does not travel in straight lines, unless there's, you know, a curvature in space-time, right? Then you're going to be
That's
in
a good
trouble
point.
anyway.
That's actually.
But we do think that light travels in a straight line. What causes the light to bend is the medium that it goes through.
So what is the, yes, and that happens all the time. And I agree. That's why I think you can see even 10 miles away light, right? Because it refracts and bends like, you know, from the atmosphere and whatnot. So, but you have to be consistent throughout. You can't cherry pick, right? And say, well, for these days, like to explain why, you know, the ice is there is because the light gets refracted or whatever in such a way, and it only focuses here on the ring.
But we,
And we shouldn't cherry pick gravity either, right? There should be some kind of a consistent consistency to it.
Yes,
Like
yes.
in terms of, you know, a force that's strong enough to hold a continent to the bottom of the ball or trillions of tons of water, and yet weak enough that you can release a helium balloon and it can counteract gravity.
Yes, but I think it is consistent, right? Therefore, you know, when you look at massive masses, then they have the gravitational pull that is expected with a single equation, and it has exactly the same
how do they know the mass of the objects?
That explains
Put it in the equation.
That
it has the pressure of all the, there's the air, right? And it is a lighter medium, lower density than the air. It's a very simple idea, right? That like, even though there's gravity, imagine that you're being punched a million times, right? By a million people, you're going to be flying up the air, right? No matter how much you think you weigh. That's the thing. That's the difference of density, right?
I agree that it's density.
Well, so to bring it back to your question about lightness and darkness,
yes.
if the Earth was evolved, then would not the North have the same amount of sunlight, or the North and the South be a similar condition? Whereas the North Pole during
no,
their
it
summer,
shouldn't. No. Otherwise, there would be no
has a lot-
seasons, right? That's the beauty of this.
Oh,
that like you have, if it was.
I disagree with that.
No reason, by the way, that the Earth would be, because we're thinking that somehow the sun is far away enough, say that it seems to be parallel to the Earth, right? But imagine that, like, relative to the spinning axis of the Earth, assume for now that the Earth is spinning, right? That the sun doesn't have to be exactly like on the equator of this like spinning axis or perpendicular to it. There's no reason, right? Because the object could be like formed and spinning anyway. It could be even spinning like this way and the sun is here. That'd be cool. But it would be a very different thing. You have something very hot over here because the sun is always hitting it, and then something very, very cold on the other side. But if you have something in between, then you have a little bit of both. Where one of them is getting more sun, the other one's getting less.
What's Polaris doing then? That's kind of confusing in the flat Earth model because Polaris stays in the same location year round.
What's wrong with that?
Well, if we're tilting back and forth, moving 66,000 miles an hour around the sun traveling 660,000 miles an hour in Polaris, you can look through it with a pipe year round, and it'll be in the exact same location in the north. So why isn't Polaris like moving its position as we tilt rock back and forth and scatter throughout the galaxy?
Let me ask you something else. Let me turn this around and ask this. Why is everything else moving? And why is it that the one thing that seems to stay almost like at the same place, we literally call it the North Star, and there is a thing in our language, right? That means like the thing that is a standard light, the thing relative to which you understand who you are.
Do you think it's traveling with us? Or do you think it's just in the same place all the time and we move so much vast distances that somehow our relationship with the North Star remains the same through eons?
Oh, I'll be honest, right? Yeah, I don't even know. I'm a quantum physicist, so like I have friends. One of them discovered the new planet, Planet 9, right? He could probably explain all of that very well. But I would just say relative to like, that statement, why is everything else moving, right? So, if that is somehow an important, statement for flat Earth, why don't you also mention that everything else but the North Star seems to be moving?
No. Everything else is moving, but you go back to that same day next year and everything is right back in the same place. None of the constellations have lost cohesion. No parallax is noticeable. Like when you check on it 1 year later, every constellation and everything's in the same spot.
Yeah, this is very beautiful idea within mathematics, not even physics, called periodicity, right? So for example, if you have something that you're a bucket of water and you keep going like that, it's going to keep spinning around for a while. And maybe it's going to have, because of friction or whatever, it's going to, slow down at some point and stop. But, if you also know that like you play roulette, right? And you kick the ball, you just throw the ball, and it spins and spins and spins seemingly forever until it comes to a stop, right? So why does this happen? And it doesn't just like, stop after a second. It's because once they are set in motion, imagine that they all came together and because of gravity, right? They're starting to swirl around its own mass and start to compress. And some of them that are too far away are not being, sucked in, say to the sun or whatever else. And they keep like having this beautiful dance that continues forever and ever. And it's not actually the same, right? Over eons, it changes as it should.
Where do we have the proof for that though?
Yeah, I don't
We
know
don't have any proof of that.
Where constellations have changed.
In all our experiments,
Parallax.
stays the same.
Let me ask you this. What data do you have and where did you get the data?
It's the same data everybody else has access to. Public data online. You can get it in libraries and you try to track that.
That's my point. Where did you get the data? Who did the experiments? Who actually built the telescopes and said, okay, what you see is what we see and you can confirm all of that?
this is the mainstream data telling us that these constellations have been there for thousands of years. We say allegedly thousands of years because we can't verify that. But
yeah, but this right, a bunch of other people over hundreds of years. I don't know how long they've been. Tycho Brahe and others build, optics, and they've been looking at it, and it seems to be very, very solid. It's not exactly the same. There is small fluctuations, as they should be, right? But it seems to be pretty like, and a clockwork machinery.
Exactly. It's a big clock. The sky is a big clock, and it has changed.
Clock a lot.
Sure.
Like if the sky is operating.
But the question is this, right? Where does the clock mechanism come from? This is what I want to focus on, right? As a scientist, I really don't care whether, again, it is heliocentric or geocentric model or the Earth is flat. What I find exciting is that you could come up with a model that may be right or wrong, right? That could tell you something beyond the original question. What if, right? Because if you tell me, oh, it's a clock because there's a massive thing and it's literally just like a clock and all that stuff, who built the clock?
We don't
well, that's philosophy.
The creator.
Yes.
And here's a beautiful answer. Nobody did. And I can take you through a beautiful journey where you will I will blow your socks off, right? And I'm not even talking about, and then it was God or Jesus or somebody who put everything together. Where you can get to see, forget about space and time and all that stuff, right? Where did the laws of physics come from that could create even the notion of rotating around a clock with respect to clockwork, timing,
Do
right?
you feel you know the answer?
Yes.
Tell us.
With using logic, we know that clock, somebody put the time in to design that clock.
Yes.
Somebody put the time in to design the gears, to put them all in place. And so,
let me ask you, who designed the designer? Who designed the designer?
I have no idea.
That's where we're going, right? Who designed humans? How many of you believe in evolution as a beautiful idea?
Why is that any more relevant than saying that nobody designed it or that it came from nothing?
personally,
How is it more believable to say that it came from nothing rather than to say that it was intelligently designed by the creator source or the source of whatever? How is that more believable?
It didn't come from nothing, right?
How did everything come from nothing?
Oh my God.
That's what they say. They say, well, they don't say nothing, but they say the singularity. What is the singularity?
About that. That's not correct. The Big Bang and all that stuff. No, it gets better.
We don't like that either.
It
How
gets
so?
better. So what you said, no matter how fantastical it may seem to you, I will have this conversation with you, and I haven't had it even with scientists yet, okay?
We're super scientists.
Exactly. That's why you're the right crowd.
Everyone is a scientist.
Yeah.
I agree.
He knows.
And sometimes that cuts you in the eye. You fall off the cliff and you forget your superpowers, right? So what if I told you that everything comes from nothing?
I wouldn't believe you.
How would this, right? That's pretty messed up. That's weirder than saying that the Earth is
Very
flat.
anti-Occam's razor.
Okay. So let me ask you something, right? When you think of nothing, what do you think of? Do you think empty space, emptiness, like something without anything, right?
Void of life, void
of anything.
I think
right?
of
Unlimited pot. This guy's a fucking genius. This is my answer. This is the end of the story. This is the end of the story. What this gentleman just said here is something that maybe two of us now have understood about emptiness.
I missed the answer. What did he say?
The answer is full of potential. You know stem cells, right? When you first see a stem cell, I don't know if you've ever looked at the stem cell, it looks like shit. It looks like nothing, right? And somehow it is possible to differentiate. It contains within it enough lack of structure, but enough potential to become anything, to differentiate into liver cell and skin cell and heart cell and all the things you can imagine, right? Because it doesn't contain enough DNA to tell it exactly what to become. It contains just enough to be able to be anything. So when you think of nothing, what if I tell you the obvious? That nothing has no constraints. Think about something that exists. How do we define something that exists? We look at it, we observe it, right? We look at its properties, we look at its structure, and we're like, all right, this is something. By existing, immediately you can ask questions. I mean, it will give you answers. It will have to say something. I am
But something's opposite of nothing. Like break down the word nothing. It literally tells you it's no thing.
Not the opposite. It is nothing is the mother of something. This is what is beautiful. It is a different type.
How does nothing become something? Like, let me say, okay, like if you have like a set of objects, like a rock or some pulp from a tree or something, and it just sits there, how long does it take before that turns into something on its own?
Crowd, I love it.
And that's something in itself to begin with, so it's not even nothing.
Thank you.
Right, you have to start with something, but when does it turn into something else? Because
this is a great question. May I take a moment to at least give the answer I had to give myself when I was thinking about this, because I had exactly the same question. How the hell can nothing, right? So when you think of nothing, what do you think? Think about it. This is a weird sentence to ever say, right? When you think of nothing, what do you think?
Think of the boundaries.
I think of no thing.
Very, very smart. You think of the boundaries.
What was that, Pancho?
I think of no thing. Nothing.
Ah!
So I can't think of anything. It's empty.
But that is not true. You're not thinking of nothing. You're thinking of nothing.
Okay, but that's inside my numpty in my head. That's in my head.
Exactly.
I understand what you're saying. Something can come from nothing. A thought, something, nothing in my head can come to something. I understand that, but in creativity, rock and gas and everything didn't come from nothing.
Yeah, you just created something. How did you do it? I will blow your fucking mind.
Yeah, I thought about it. That's different. That's in my numpty.
You're talking about a consciousness here, so now you're kind of referring like a God is creating everything through potential will.
Forget even about consciousness right now. Okay, we will get to consciousness. This is an emergent phenomenon, right? Because Sasha already said something really important. Right?
I say that a lot.
First we heard nothing is full of potential because it doesn't have any constraints, right? It has no structure. The second thing we heard is how do we address nothing? How do we think of nothing? We think of its boundaries. We think of the container that we put it in. The thing that is emptiness itself, we cannot grasp. We cannot speak of nothing unless we put it in a container that points to the concept of nothing.
Next to something.
And then that container of nothing is the first thing that exists. Booyah.
Okay, well, can I change the subject?
Well, wouldn't the container already?
Yes.
The container is something, though. It's not nothing.
Precisely. The container is something.
Okay, Spiros, who's on first?
If you were nothing, you wouldn't be able to think of the container, be the container that was nothing, right? You could not contain the concept of nothing. You have already been born through nothing. So by definition, you exist and you can imagine even of the concept of nothing. So you have created the first object, the container of the concept of nothing. Before we change the subject, the reason why I'm bringing this up, I'm not just talking philosophically here. This is the foundation of 3 different sciences: mathematics, physics, and computer science. In computer science, if you try to create a language out of nothing, right? What do? The first thing you allow yourself is the concept of empty. Yes.
Because math isn't science because you're not observing.
No. Sorry. Yes, I agree. I'm a mathematician. Okay. It's meta science. It's a framework.
Computer work is not a science.
Computer science is a science.
No, you're not observing a phenomenon.
Yes, you do. You observe computations.
Natural science here.
Oh, I see. You're talking. No. Sorry. What I mean by science is not just natural science. There's social sciences. There are natural sciences. There is computer science, right? So yes, as far as natural science goes, this is the science of observation.
And that's mostly what we do.
Yeah. But you can imagine that
you want to know where we live.
No, of course, but you can also imagine that computer science is a very real thing because it's everything we're using right now is based on that, right? Yeah, exactly. So
I'm also hearing a little bit of a contradiction in what you're saying, because earlier you said who created the Big Bang, or who did that, and you said no one did, but then just a minute ago you said you created the container. So you're saying that we create the container for it. So that implies a creator. That implies intelligent design. So how can one side of it, no one be creating it, and then the other side, us, we are creating it?
It does not require an intelligent designer. I know why you're saying that, but that's not what it requires. It requires an observer. It requires the existence of something that was birthed out of nothing. The first observer. The first thing to observe, right, was the one to come out and say, I can now, like, you know, put a container around the concept of nothing.
Because there's no force greater.
And I want to say it in a way that, like, let's not go metaphysical yet, right? That's why I was trying to say computer science and logic and math and physics are the foundations of these sciences, or even physics, right? Where we use physics to understand the world, is actually based on this very simple concept that everything comes from the concept of nothing, which has 3 different names along these different sciences, okay? In mathematics, it is called the empty set. You should check this out, by the way. It is amazing. But how do you create the concept of numbers? If all you have at the foundations is set, right?
What set of numbers is?
Every set of numbers. Imagine you're starting with natural numbers.
It's based on what, like, base number set you can do operations with.
Yeah. So how do you even? What is a number even, right? Try even to
a number is to count something, to account for a value.
Imagine that you don't have that. Imagine that you only have the concept of, like, you know, an element that exists relative to some collection of objects, right?
Okay.
So,
well, I as much as I do like to kind of foray into the imaginary, is what I do a lot of times when I'm in kind of my own, like, flat Earth research and stuff like that. It's like, it's a little bit difficult to, like, I don't know, at the same time, to hear your kind of critique on us, that, like, or what you might, or not maybe on us, but, like, just on the flat earther, the concept of one, is that you have to kind of reject some authority, and that, in essence, like, who can you trust about the data that you're receiving? In a sort of inverse way, we're when we start stacking up, like, physical evidences and kind of presenting them to you, we lose cohesion on what we can really agree on as a physical agreeable happening. You know what I mean? We get too abstract in talking about it, and in some way we need to just meet, you know, with it on. I don't know. I'm hoping that we do get to collaborate a little bit in the future, because it adds credibility to what anything that we would do if it came out to our. I
will tell you this. Listen,
if it was a well done experiment that was performed.
I want to say this right now, right? The beauty of science is that you don't need a real scientist to give you credibility.
It's
and that's the beautiful thing again about science, that
it gives a credibility for us, really. Like, I think in a way, just to know that, like,
I want to say this, right? Because I know that you're thinking of me as someone who could help give you some, you know, validation, credibility potentially to the outside world when we do experiments together. I'm like, oh my God, you know.
I don't know. I think that's taking too far. That's like way too far ahead. I don't really care. Like, it to me, I'm trying to be impartial and not really care if you're into flat Earth or not. It's just I'm just trying to go, you know, on the point by points.
I understand, and that's a fair point. I mean, I believe that.
I mean, I'm gonna, like, think you're like I like. I mean, you know, I know I've been, like, relatively silent here. I just kind of pull in for, like, a one-liner here or there in the first episode. But I mean, you know, I'm also spending the rest of the week talking about this interview and talking to people about you and planning for it and stuff like that. So I feel like I've talked to you before, even though I really haven't.
And I don't.
And just like in like when Sasha was talking earlier about, like, what it meant to her to understand the flat Earth as a real thing, it affected me in a way where I stopped worrying about comets, asteroids, meteors, gamma ray burst emissions, solar flares, you know, like the end of the solar system, the sun swallowing the earth, the eventual cosmic death that will all fall, like all of that. Like, I put all of that cynicism that really made me kind of, like, a bitter child, even like everybody recalls like at some point when you hear that eventually the planet you live on and all the people you ever know or ever would know are all going to die in a fiery explosion of the sun after it engulfs the other planets. Like that's a heavy set of like almost theological constraints that you lay on a kid. To like when I remember when I heard that, I was like, that's heavy thought, really, and it borders on the theological or the religious. I don't want to like go up that tree, but it's just like, you know, it's a profound kind of contemplation that science brings in that guise that is like, I don't know how provable it is. Yeah. Standard of proof is difficult, really, in this. Like to prove it's a ball or to prove it's flat is, I guess, demanding. But I think what we could gain from you is to understand like what would be enough proof for you.
Yeah,
you know, we know what our burden of proof. Well, we know like what kind of proof we would need to see. What kind of proof would you need to see to validate it as being flat, or would it just be a lot? Or could you certainly say that it was flat just because there was zero absence of it being a sphere, you know? And I don't want to just do it for like just the pure argument's sake of it, because just having a dichotomy of it being flat around is whatever. Like we're also not spending time, you know, talking about whether it's a cube, which I don't think it is. And I just say I don't want to like overload it or whatever, take up too much time. But the last thing I like, would you agree that the Salton Sea is a flat and level body of water?
I have no idea. I've never done an experiment on it. Until last week.
if refraction is essentially at a zero, and they're able to like spot like a point to point, if there's an optical test that can be done point to point across it, it's almost like we should be documenting this amazing like optical illusion where there's actually like matter in front of us obstructing it, where we do not see any.
I can answer that. And so you sent me a link.
Yeah.
Thank you for doing that last week after we talked to MetaBank and a few other sites, right? And then one of the first things that I saw when I went to MetaBank, which is the Earth curvature, you know, calculator, was where they say thread for discussing how they came up with like, you know, the math and so on that you were using, right? And what I saw in the thread was a discussion where somebody asked like, all right, so we had somebody from the flat Earth community do an experiment and see this, how would you debunk it? That's what they were saying, right? And then they have a bunch of, you know, equations and a bunch of threads and like back and forth, but what about this and all that stuff? And I don't know, like someone from your community, what do you think? Like, you know, I said, like, why don't you go look at that and see if you can write it?
He actually went and did a 6-mile experiment this weekend because we're like, Spiros suggested he wants to see a short distance. And we're like, let's do it. Let's come back. And they went down to the ocean.
Yeah.
And they were down there at night and they did a laser. They saw the laser, but they had some issues with the waves being very high at that distance being a factor. But we can show you.
Okay. That's fine. But yeah, what I wanted to say is that what I saw in that thread alone was like, you know, they were showing how a ship that is out at sea after like, you know, 20 minutes of traveling starts disappearing.
It's gone.
It's gone. And you're like, okay, what just happened? Where is it going, right? No, because this is the not trusting part. Because you can always say the God thing, right? That like, somebody was messing with us, right? This is things I've seen with my own eyes.
Right.
Where we're like, you know, you go to Greek island and at some point you're like, what the hell, where did it go? You know, it's gone. So
your camera
the same thing.
Right back.
I don't know. I don't know if it does.
I've done the experiment.
Because these are cameras too, right?
These two.
Zoom in.
The boat's gone. I can't see it. I get my camera out. There's the boat.
Of course, you can zoom, right? And you can get past some of the haze and all that stuff. But does it look exactly the same as before? Or is it like smaller and smaller, but you could just zoom in further? I mean, I'm just saying this was done.
Well, we have infrared now.
Like,
and we've
sure.
been going
that on that thread on metabank.com, right? I wasn't looking through somebody's eyes. I was looking through somebody's camera. So there you go, right? That's a question.
Well, you can never look through somebody's eyes.
Exactly. So they had the camera, they captured this in a camera, and then it was gone. I'm like, all right, this is interesting. The other one is actually they suggested in that like little thread, discussion thread. And I think it was, I don't know, maybe I'm wrong. It was mixed with some people that were like from the flat Earth community. Some people like were like building the site and stuff. And they suggested, why don't you just, throw some of these balloons up in the air with the GoPro and whatnot, and you see what happens. And then one of the pictures I saw there was that of the curve. And I was like,
GoPro
okay.
lens. GoPro lens is a fisheye lens.
If we keep saying all that stuff, then what lens would you trust?
But
because give me the one that you would trust.
It's a fact.
Regular lens.
No, of course, a regular lens. I mean,
What's that, Jerry?
We don't trust lenses. That's why we do experiments with lasers. I actually am part of a group. I'm part of a 501c3 independent scientific research group named FECOR. And we did go to Lake Balaton and we performed long distance laser tests across Lake Balaton. And we did cite the source of the laser from 12 kilometers and also 21 kilometers across the lake, which you shouldn't be able to do.
What was the expected curvature for that experiment, Karen?
Hang on one second.
The laser off the water.
I wouldn't even worry about the answer to that, because I remember seeing in the documentary that I spoke at, right, someone from FECOR, one of your people, that did an experiment and said, all right, we're doing it over this distance. If it goes through, right, the right height across, if it is flat, we'll be able to see it and reflect it back to us because there's a mirror for the laser on the other side. And then true to form, right, they said, okay, if the Earth is curved, as they tell us, you need to raise your mirror about 3 feet above your head for us to see the reflection. And sure enough, that's exactly what happened, right? And
but that was actually before FECOR was actually formed, and this test is a test that we did after that. This is a different test.
It doesn't matter. You can do 30,000 tests afterwards. You just need one counterexample, right, to disprove. And that's what I do also for my son.
Exactly, but we have more than one test that we shouldn't have been able to be successful at if the Earth was a ball the size that they say it was. We actually have 3.
And where are those? Are those online? Are those,
Yes, you can go to fecor.org, and we have a 121-page PDF document that outlines our experiment, the conditions of the lake, the measurements, the height of the laser, the distances, the refractive index, the humidity, the temperature, everything. Every condition you can think of that could possibly affect the light as far as refraction goes, and we beat all curve calculators, even the Metabunk one, which takes into account a 7.6 R radius of the Earth and extra refraction, which knocks the number way down. We even beat that calculator 3 times.
With lasers, and what was the experiment?
I'm sorry?
What was the experiment with the laser?
Can you describe the laser experiment?
What did you do?
Or at least one of them?
We had a custom laser built, a custom high-powered laser built with a highly collimated lens to reduce the diffusion of the laser light over long distances. And then we placed it I don't think it ever got higher than 2 meters above the water's surface. And then we went and stood across the lake where the observer height was 1.5 meters, and we were able to observe the source of the laser light.
But did you actually put a mirror at exactly 2 meters high and observe it from the other side, reflected back to you? That's the real question, right?
I don't understand what that would do.
Is with diffraction.
No.
Right? Over the curve and over the sea, because...
So you're saying it would only be valid if we shot the laser across the lake and then back across to the other side?
No. I'm asking something very simple, right? You're shooting the laser from one side of the lake to the other one. Highly collimated. Did you have on the other side a bullseye?
Yeah, we had a sheet. We had a target that we had with reflective tape that we held up. That it was like a grid.
Good. And what happened on that reflective?
What did you observe?
What did you observe?
We observed the laser hitting it, and we also observed the source of the laser light. We shouldn't have even been able to see it. It should have been far below the curvature of the Earth. We shouldn't have seen it at all.
Do you have that video? Video, not what you observed, right? This is how science is done. So do you have a video of all of that where, this is pretty amazing, evidence. So
yeah, we do. We haven't finished producing the video of it, but we do. We have the document where everything's all laid out, and we do have the video.
The video is the most important thing, right? You put out the video, and you set out the conditions, and then, you know, you have to be ready for people to tear it apart like they do with my science all the time and all that stuff, and be like, okay, but did you correct for this? Did you think of that? What about this? This is going to be the interesting part, right? This is going to be interesting because it sounds like a really cool experiment, but this is like when you put it out there into the world and you become vulnerable, right, to all the criticism, you have two choices. To either say, oh, this is bullshit criticism because it's coming from these other people, right? Or, wait a minute, let me take some of this seriously. Even if it comes from people who think we are crazy and stupid, let me take this seriously for a second, right? It happens to us all the time, by the way. People that we don't even like, you know, because they're like, you know, rejected their papers before and all that stuff, but you have to take it seriously because you want to know, did you miss something? Okay, so when you do that, and I can help with that, even though I'm not, you know, an expert in these things, but I can help with that. That is huge, and that is really cool, and that gives you legitimacy, right?
Yeah, we do. Well, we have sent it. We've shown it to a lot of people, and nobody has been able to refute our evidence yet.
Other people,
just everyone, anyone who wants to look at it. In fact, I'll send it to you. If I could get your email address, I'd be happy to send you a link to it.
We can share.
Yeah, you can send it to me also.
Yes, but that's again, like, that's why, you know, when I went to MetaBank, I don't know if you had seen the thread before, right? And it's a serious thread, right? You can look through and, you know, you can see what they did. They have it out there. That's the beauty of science, right? That it is its openness. That yes, you put it out there, and then you get beaten to death, right?
And we're certainly open to that. We are performing these tests and these experiments, and we are open to criticism. We want everybody to look at it, and we want everybody to try to tear it apart, because ultimately we only want the truth.
And you want to like collaborate with us on any level?
Oh no, I think it's amazing. I think it's amazing because I will tell you this, Karen, right now, right? If what you're saying is right, okay, then it's not like, oh my God, the Earth is flat, and I'm like convinced. Maybe, you know, after many like such experiments and whatnot, I'll be like, oh, this is interesting, even though there's so many other evidence in my head, but forget about that for now. But it'd be really interesting to figure out why it works, even if it is curved.
Sure.
Imagine that, right?
Sure, yeah.
How crazy is that?
Mm-hmm.
Because then it refines your experiment, because it says, okay, wait, we can't trust this experiment. The problem with science is that it doesn't give you affirmative evidence. It throws away all the things that are wrong. It doesn't tell you what is right. It just keeps zooming in, right?
Right. Observable, testable, repeatable. That's what we're going for.
Yeah.
Why, when we do experiments, we observe level oceans, and what does that mean? And
I see. So okay. So this is another aspect of science that I want to bring in that we didn't discuss up till now, right? There is no such thing as just observing evidence and then saying this is what this means, without interpreting the evidence relative to a model. Right?
I mean,
and we discussed that a little bit, like either the Earth is flat and there's no reflection or diffraction or anything that messes with the light as it's moving through.
Or there's a little,
right?
and we're accounting
or
for
even
it.
there is a little and you're accounting for it and it's still flat, right? Or there is other processes that, you know, you haven't even considered, and maybe out in space you
don't isn't pre-assuming a model, though, kind of a biased approach?
Yes, it is.
The neutral evidence.
Right. It is definitely a biased approach, and that's the beauty of science. It tells you your model is shit, okay? Because it doesn't account for what we just saw. But if it is an amazing model, then not only does it account for what you've seen, but maybe makes a crazy prediction, like quantum physics. It doesn't just predict like this interference pattern of like things moving through two places at the same time. It says like, you should be able to do this experiment also, which you've never thought of doing, and you should be able to see this. And then you do the experiment and you're like, what the hell?
Sarah, can I make a request to you that you can say yes or no to? Kenny has collected a few images that make us suspicious of the globe model or of NASA.
Yeah.
You don't have to commit. You don't have to
through them.
say
How are we doing with time?
We just want to show them to you.
Oh, we're good. We're good. Yes. With impressive music.
I was going to call it a safari.
The Valkyries.
Journey. He objected.
Okay, quantum flat Earth.
Quantum flat Earth, where some of the time is flat, some of the time is globe.
We're willing to negotiate.
That's more like it, actually.
Let's collaborate on it.
The many worlds.
The
many worlds.
So, Kenny, do you want to introduce what we're looking at?
Yes, sorry.
Okay. This was 1972 takeoff.
Yes, Apollo space program. Okay.
Hopefully this will work. Oh,
Eagle
that's
eye.
not what I want to show. Hold on. Wrong page. 1 second.
Can I ask, in the meantime, Karen, what is your background?
What is my background?
Yes.
In graphic design and printing.
Cool.
I don't have an official scientific background.
Well, it seems like you're an actual scientist to me, so that's good.
Well, because I spend my time learning it on my own. I don't think you need to go to school to learn anything. I think if you can read and you take the time to learn it and you care about it, you can learn whatever you want. So that's what I do.
I'm with you. I think that's really awesome, actually.
My screen?
But having said that, despite, poo-pooing the academic environment and being inside of it, I know like its faults.
Well, I'm not poo-pooing it. I'm just saying that I didn't go through that system.
Karen, he's not saying that.
Yeah, I'm poo-pooing it, not you. Because
okay.
Oh my God. No. Yeah. My own people suck. Anyways, but there are aspects of academia where you're forced to just hang out with a bunch of people that are always trying to tear down your idea because they want their idea to be right. But it's a mutual hatred, right? Which somehow, it's kind of like when you run by yourself, 100-meter dash, and then you run with the person you hate the most because they're your rival, and then they make you run faster. You break your own record simply because they're right there. Even if they win, you beat your own record, right?
It's wonderful to have opposition in your life.
Then we get the egocentric model.
But it is, in the big picture, wonderful because it pushes you exactly to places you may not have considered.
Okay.
Yes.
All right, let's take off. Apollo 17.
Where is this from?
This is from the moon.
Oh, where is this laser light?
Do you see something that looks fake? Because we see something that looks
That's
fake.
the official
I'm just gonna put it out there.
Official.
Let's show it like 3 times in a row.
Official NASA footage.
No, but I want to see that again. Like, are there any
let's
other?
show it 5 times. I had to watch this myself like 10 times.
3, 2, 1. Boom. That.
So, where did you find this?
This is NASA. It's from NASA's website.
Can I see? Can we go?
Yeah. This is all public domain official stuff.
Because this is really interesting to me,
Yes.
right? That there's like a psychedelic, explosion of light in the beginning.
It's like firecrackers.
Here, you want to trade with me?
There's your
Yeah.
You can sit there.
Oh, yeah. Are you guys switching?
Yeah, give a better cue.
So you also,
Oh, okay.
Are you okay with that?
Yeah.
why do we not trust some official sources?
Yeah.
And we're going to show you
Yes.
a couple of reasons why.
Come on, remember that was
Okay.
the 70s.
Last
Everything
time.
looked like
Last
this.
time. Last time. Here we go. 3, 2.
Oh my God! It's like Jesus and Technicolor or
It
whatever.
looks like Thanos' glove exploded.
All right. So that's one. All right.
That is
Well, I'd like to know,
official-
I honestly would like to know your take. Like,
Well,
what
Let's not pressure me yet.
I mean,
No, it's fine. It's fine. I think.
what do you think of that? Do you think it's real?
Do you know what
do
that
you think
is?
that's on the moon?
Do you know what that
no,
is? Do you know what that is?
That looks like the Earth, the thermal part of the Earth.
That's Earth without water.
Says NASA.
That's the model.
NASA.
Yeah. Okay.
So everybody says all the other bodies in the universe are round. Why is Earth not round? If you take away the water, it's not round.
I mean,
It's like a funny shape.
I don't know. That is weird. Why? I don't know. What this
That is not the Earth without water, y'all. Just so you know.
All right, let's move on. This is I'm trying to do this quickly.
Is this from Star Wars?
This is
Good question. NASA.
1972. You ready for this?
Yes.
Okay, watch this.
There's a mountain of
This
evidence.
is our comedy.
This is a redocking with the lunar orbiter. Does that look real to you?
Do you really think that this contraption made out of
I'm gonna look at the person down the.
Wait. No, I asked this before. This is obviously
NASA's footage.
No, this is
NASA's
this is someone else. I'm hearing somebody
No,
else.
this is NASA. This is what NASA shows us.
But I want to know, like, I want to see the same footage from the original.
Yeah, he's gonna be a flat earther.
You want to see something really funny? Look up John Glenn piloting his thing around the moon. That's even worse.
No, I mean, I want to see where this is. What is the source of this? Because I know you're telling me NASA.
NASA's the source of this. JPL, NASA.
This is what we're seeing. This is what NASA gives us.
This is why we're who we are.
That's what I'm saying. I want to know what NASA gives you.
Not that. Give us that.
Spyro, that is it. I'm telling you, that is official NASA footage.
But I'm telling you, as a scientist and a super scientist, you need to cite your sources, even if it is an exact replica.
Okay.
Right?
And he's going to give me the sources.
That's very
and
important.
I'm going to email them to you.
Because that legitimizes things 10 times more. Right?
Yeah.
I'm going to play one.
Spiros, I just want to say, when I first heard about Flat Earth, I thought it was the dumbest thing I ever heard. I thought it was incredibly stupid. I thought it was the dumbest shit I ever heard. And I watched the only reason that I clicked on a Flat Earth video was because I was going to embarrass and crush the person who posted it on their Facebook page.
I'm not the barbarian.
And I set out to debunk them. And the first thing I did was I went to NASA, I went to space.com, I went to all these official sources to try to debunk Flat Earth, and I could not do it.
Yes.
Okay, ready?
This one? Yes. Where are we watching?
Let me turn this volume up so you
this
can
is
hear.
GM
Okay.
over our square.
Let him just.
So what I'm saying here is, if you follow where I'm going with this, how do we know they didn't guess, or that Cavendish didn't guess this mass of Earth? And then just use it to solve for G. And then do the opposite and say that he did this. He solved for the mass of Earth using that value of G. It's the same
Wait, I'm a little bit confused.
thing, just based on the algebra. And then if you plug both of those values into this equation up here and use the mass of any object, whether it's a man, a horse, a carriage, anything, and use the radius of Earth, you're going to get a force that's equal to the weight you get for that same object if you just multiply the mass of that object's time the acceleration due to gravity, or the rate at which the acceleration at which things fall towards Earth.
Okay, so what is the problem?
Seem far-fetched?
He was asking,
I don't know.
how do we know that Cavendish, who is the one who developed the big G gravity, did not guess the value of big G and then reverse engineer or do the math and reverse it and just use that guess to find what the little g and the mass.
Yeah, we asked the question, how did they know the mass of the moon in order to calculate the gravity for trajectory and fuel and all that? Now, how could they possibly know the mass of the moon?
I think this is because they never did the experiment and create this, this equation, right? Newton's equation, just from planets. They was tested also with much smaller objects, right? Where you needed the precision to be able to tell, right?
Wait, hold on. How was it tested on smaller objects?
Because
like where would? Can you give me an example where, even on a small scale, not even a planetary scale or anything, on a small scale, besides the Cavendish experiment, because he was after Newton, keep that in mind.
Yeah, the Millikan oil.
Can you give me an example of smaller objects being drawn to each other?
Josh, I think, like as I was saying, the Millikan oil drop experiment, where you have an oil, right, and it drops, and they're saying, okay, let's plug it into this, figure out relative to every other value we have for the the electron charge and so on and so forth, and magnetic field. Does it cancel and does it suspend itself exactly as we'd expect relative to this value of G? And it does. So we're like, okay. So that's one way.
Wait, it sounds like you're talking. Okay, were you just talking about electromagnetics right now, though?
That's right.
That's not the thing.
That's funny because Coulomb's law is actually like the exact same. Because you're a numbers guy, man, right?
You're including electricity in the equation.
It's a numbers guy.
It's fine. So sorry, I missed the last one.
No, I was saying you're a numbers guy, right? Like that was your whole deal in college and everything.
One of my things that like haven't used numbers.
You solved that equation like Beautiful Mind, right?
Yeah. I'm Nash. I went crazy in 10 years.
So, like you mentioned electromagnetics, man. Coulomb's law, right?
Yeah.
Familiar with it?
I've heard about it. Yeah.
Okay. It's actually basically it's the same equation as the equation for gravity. The Fg equals big G times M1 times M2 over R squared, right?
Yes, that's right.
Okay. Coulomb's law is what is it?
Fg over K1 K2 R2 squared.
Thank you.
Thanks, Pancho.
Which one?
Okay.
The Coulomb's law.
Coulomb's law.
Yeah, Coulomb's law is that. That's right. And then it looks very much like gravity, even though it has supposedly nothing to do with gravity. So that should tell you something. Right?
Okay, so you being a math guy,
unified.
When you're doing algebra and the variables, right?
Yes.
Does whatever the variable is, does that really matter? Like whether it's an X, an L, an O, a P, a Q?
No, it doesn't matter at all.
Okay. So when you look up Coulomb's law and you look up the equation for gravity, dude, it's the same exact equation.
Oh, this is I was tutoring my girlfriend like a couple of years ago for the GRE, the graduate exam, get into graduate school. And she was like, my God, these look the same. I'm like, isn't that wonderful? You don't have to memorize 2 different or 3 different or 4 different, whatever. There is one.
So why not just get rid of one? The one that we can actually, or the one that we can observe, and keep the one that we can observe.
But that's the thing, that they correspond to very different forces. One of them is electromagnetism, the other one is gravity, right? So they're very different concepts, where you can imagine.
But they're concepts, or
how are they different?
They're very different. Why? Because there is a concept of a charge, and you can rub onto something and then you can pull stuff up, right? That's a charge. But there's also a concept of a mass. Mass can exist without any charge, and a charge can exist without any mass, for example.
I wonder, why don't my leaves break themselves? Like, why doesn't mass?
Fantasia.
Why is it entropy instead of things drawing to each other?
Because again, if you plug in the mass of the leaves into this equation, there is just no way in hell like they're going to be attracting each other, because they're all attracted towards something else.
What kind? Well, can I ask? It's kind of an important question.
Very small.
What kind of a force is gravity? Like, what kind of force is it?
Yes, we have a ringer. Sorry, that's all the good questions there. So, gravity is not a force. It is an illusion of a force. Okay? And I know you enjoy this, but this actually goes at the very foundation of what is wrong with the flat Earth theory. That not only is space not flat, and hence, like, the Earth is flat, it is like, sure, but space-time itself is not flat.
Prove it.
Where you have space and time. So here's how I would prove it, right? Now,
is it using your imagination?
The first proof was given by observations, right? Where you don't have to assume flatness or anything in the world, and they were able to see a single star appear twice, right, in an image. Why? Why a single star appear twice and move perfectly in alignment with each other, even behind an object, behind another massive object? It's because of something called gravitational lensing, where even the light from the star was, instead of traveling like a straight line and hitting the planet or whatever the object in front of it, and then it'll be invisible to us, it would curve around the gravitational field of that object, and of course, it would curve in both sides. It didn't have a specific direction. It would I want to go this way. It would go both sides, and then it would create the illusion that it was coming from 2 different places.
But that's a theoretical explanation for a real observation.
That's right. And before that, we were like, we have no idea what the hell is going on.
But it's still it's still a theory. It's still not proven that that's what's happening. But the observation is real. The explanation is a theory.
Because don't we have to be able to prove lensing, gravitational lensing at some level?
What was that? Sorry.
Even on a small scale.
Yeah, how do we prove gravitational lensing?
You said that we agree.
This is the stuff that you can see, I guess, with yourself, like with a telescope and whatnot. So you can check gravitational lensing online. Right? And keep it open mind.
Well, we'll see that thing that we're supposed to be observing that's called gravitational lensing, but how do we know that the gravitational lensing explanation is actually like solid? It's proven.
So this is okay.
It's as if we came up with like ether sciences and then said that to you that they're happening concurrently with other effects and that you don't see them or can't observe them. If we're talking about like gravity, gravity is not an electromagnetic force, I guess.
Sure.
What would you define it as?
So what is the question, right? The question is, how do we know that the theory, right, explains this phenomenon, or that it's Einstein's theory that is responsible for explaining it? It's because when Einstein came up with his theory of both special and general relativity, he did not expect that this is something we had not observed that yet, right?
Well, they were waiting for the eclipse.
So what did they do?
To see it, right?
No, it wasn't even the eclipse. Maybe the eclipse could help. It was actually something else. It's just like in quantum physics. Before we knew a theory that could explain what we had already seen, but ended up being interesting enough to predict stuff we hadn't seen, right? It ended up giving us things that we said, all right, he said, because people didn't believe him. And it's like, no, but I think it's how it works. How could you possibly be right that space and time are one block universe and there is curvature in between all stuff, just like the Earth could be not flat, right? And he said, all right, maybe I'm wrong about this, but if I'm right, we should be able to observe this thing that nobody had observed for thousands of years, right? Like just point towards something massive, potentially where we expect a star from time to time behind it. And if you wait long enough on the line, you will end up seeing, instead of just one image of the star, at some point, two of them appear. And you're like, yeah, whatever. And then there he was, right?
What do you think of the double
this is messed up coincidence.
What do you think of the double slit experiment?
Yeah, that's quantum physics. This is my favorite thing. It's really cool.
What do you think's going on there?
Well, this is beautiful. Like one of the world experts of light came from Caltech, Richard Feynman.
Of course, Feynman.
He's a crazy cool guy, right? Played the bongos.
Crazy guy.
Talked about orange juice. Yeah, that's right. He's really.
He goes, if you don't understand the math, I can't help you.
That's right.
Wait a minute.
He said better things than that. He said, if you think you understand quantum physics, you don't.
I just call bullshit on that. Yeah, I'm sorry.
No. But this guy knew exactly what he was talking about.
Well, I still think I can understand what he's talking about.
Oh, yeah, that's because he's amazing. That's because Feynman, that's why he's so well known around the world, right? He was that good. That's what was my point.
Yeah.
He was so good, he could explain things that like to us seem like bullshit, right? And he's like, all right, how could it go through two slits at the same time? And the idea is this, and it's a beautiful idea, right? That's why I was talking about these philosophical concepts before. Because you guys are very deep thinkers, and you're missing, I think, that foundation from which like you can say, holy shit. This was upside down the whole time. Our understanding of the foundations, right?
Yeah.
This is the cool thing. So imagine that light does not travel in straight lines. That is false. Light does not have, right, a finite speed that is constant. Okay, but it seems like it does. It seems like it does. And like every other law of physics, it is a really good approximation to the truth. The same way that I said last week, if you think that gravity doesn't exist, fly off the top of a building. Good luck, right? Now, even though I'm the same person say
how many times I've heard that shit
all the time in quantum physics. Okay? But there are some things that become laws because they're so likely to happen, you don't want to bet against them.
Buoyancy and density is also laws that are provable. Gravity is a law that's explained by buoyancy and density, and to think that the thing that makes an apple drop to the ground is the same force that's making lights in the sky move is a little bit of a major jump in major theory here. Like, I don't know how you make the correlation that the apple dropping is what makes the lights in the sky move and the moons move around the other bigger lights in the sky. How does one bridge this connection? And how does this guess hundreds of years ago end up being proven as a fact today. This is like, wow, what a lucky guess. That's one of the luckiest guesses in history.
It is.
Well, you know what? That's what's making the lights move up there.
That was more of a legend.
Later, we're going to find out that that's true.
By the way, I want to say like something, right? Because there is this apocryphal, like, stories that something fell on his head, and he's like, "Oh my God!" Figure out gravity. Never happened. Okay, he spent like decades working with other brilliant minds, stole their work, and then said like, and he developed calculus to figure all that stuff out. So there's other reasons behind it, not just because an apple fell. And he's like, everything moves around this.
I have a question about gravity. Sometimes I've like talked to people and just discussing gravity, and they say, it's mass. It's mass that creates gravity. I don't know if you.
That's not true.
Okay, so because to my mind,
because then light wouldn't be gravitating, as I said, you wouldn't have any gravitational density. That's where Einstein came in.
Does the force of gravity prove a spinning ball? Could we have gravity and not live on a spinning ball? For example, the mass of a huge flat Earth or something. Could that be creating gravity?
Of course, the spinning is just an extra, like a bonus thing.
And so even if we agree, not necessarily agree, but just like, okay, sure, maybe gravity is real, even though we don't really agree. But even if we're like, you got gravity, we'll give you gravity, it still doesn't prove the spinning ball.
Yeah.
So.
Right. The spinning ball could be like from anything else. You could say like, okay, you zoom out and you see the Earth moving, or you're like, oh, there are seasons, why?
Without NASA, how would you prove the spinning ball?
It depends on this is relativity, right? Because it depends on whether you are spinning or staying always and seeing the same part of like the sun, right? Why is it that you have different seasons and so on and so forth. But I don't know. I mean, I'm sure there are clever experiments. That's what I'm talking about, right?
I'm sure, but there aren't though. That's the thing. There is nothing that proves that the Earth is spinning. There is no empirical evidence that the Earth is spinning and the heavens are not. There is no empirical evidence for that.
I expect
it was Aries' failure.
I expect less strong statements from you. You're a super scientist, right? There's no empirical evidence that the Earth is spinning.
That's correct.
No paper.
That I could
reviewed paper, Spiros.
Spend 5 minutes, and I don't have any myself because that's not what I do, right? I don't think about that. I could spend 5 minutes with you on Google, and then we would see empirical evidence. And then you'd be like,
no. I don't want to Google it. I want to see it. I want to experience it with my own eyes. Because here's the thing. The Earth, there are like 5 different motions that the Earth is supposed to make. The Earth is spinning on its axis. Then the Earth is also rotating around the sun. And then the sun is rotating around the universe. So we have all these different motions that the Earth is supposed to be making, which equal up to like hundreds of thousands of miles per hour. And we don't feel any of it. It cannot be detected. What is the proof?
When you're going, like, have you ever traveled at 90 miles an hour in your car?
Yes.
Can we spare this one? We do this one all the time, but
No, I want to talk about this. I'm perfectly happy talking about this because here's the thing: when you fly on a plane, when you get on a plane, like I'm sure you've flown across country or wherever you've gone. Okay, when you're in a plane and the plane is on the tarmac and you get on the plane and you board the plane and you walk to your seat, it's very easy to get up and walk to your seat and you go and sit down. Once the plane is in motion, now it is more difficult to walk on the plane. People always say that they don't feel the motion, but I don't believe that. You do feel it. What about when the plane changes direction? You feel the inertia of the plane changing direction. The Earth changes, your position on Earth changes direction twice a day, and we don't feel it. You don't feel that inertial change, and you should feel it.
I agree with you that you're right, that you feel a change when you're moving in a plane versus like when you're in the tarmac. But this is what we call a second order change, not a first order change. What do I mean by that? If you're traveling at a constant velocity, whether it is 100 miles an hour or like 5 miles an hour, you can't tell the difference. It is only when you're accelerating from zero, right, when you're sitting, to accelerate very fast, and you know I'm right about this, right? You go into a Tesla or even like a nice little Mini, and you go zoom, and all of a sudden you're like, okay, this is great. But then the moment you hit 100 miles an hour or 80 miles an hour, you don't know you're moving anymore. Only by looking outside are you like, oh, I'm feeling the same. Like, you know.
But would you not?
But if that car flips over, you damn well better believe you're going to feel that change, right?
I want to focus on that, Karen. Why would you know?
Because we have an elliptical orbit.
No.
So we're going to change acceleration.
Because of a massive deceleration. And just like the acceleration hits you, the second order effect, a massive deceleration from 100 miles to 0 is why you die.
Okay, so Spiros.
Right? You never.
But the thing about Earth is it's a non-linear motion. It's non-linear. It's changing all the time. If you're driving down a road, that's a linear motion. If you're flying in a plane, that's a linear motion. Once you talk about spinning in circles, it's like you're on a carnival ride called the Scrambler. It's non-linear. You're constantly changing direction.
You know what that feeling is called of the non-linear motion of the Earth?
What?
It's called gravity. It's called gravity. Is the reason why when you jump.
Oh, you mean the gravity, the same thing that's an illusion? That gravity?
That's exactly my point.
It's not real. It's an illusion of a force. It's an illusion of a force, but we're feeling it, but we're not feeling it.
Yes. Yes.
How does that make sense?
It's because mathematically,
okay, but in reality, unmathematically.
No, I'm going deeper than that. I'm actually trying to show you something deeper than the observation as human beings, that we're stuck to the Earth. Go ahead and fly. If gravity is not real, go ahead and jump 30 meters into,
I can fly with a less buoyant material.
That can be explained without gravity.
Like a balloon.
Hey, Spiros, can I ask you a question?
A vacuum chamber, and then try to jump very high. It is not going to make any difference.
That's my third proof. Okay.
That's a logical fallacy. Hey, have you ever looked into the electric universe theory? Have you ever looked into that at all?
There are many theories out there, and I have only looked at the ones that, are the simplest theories that seem to explain the most, right? Because I don't know what the electric theory universe is, and there's a lot of other theories out there, and I don't know how many people even know about this. But, I know the one that seems to explain everything, like everything. Not even, it's like, oh, but what about gravity?
Then what are you doing?
You know what, though? It doesn't explain the lack of motion or the lack of curvature.
Everything at the macroscopic universe. And what I need to do is understand how it explains things, not at our level, but at the level of the microscopic. I don't think we're discussing quantum gravity here. This is what I'm trying to understand. How can gravity be a force as the curvature of space-time? What the hell does it even mean? Which means also that if we have a construct called space-time, where does it come from, right? And what does it mean to be curved, like my T-shirt?
I wonder if I can.
Hey, Poncho, do you got something you want to show? Because we're running out. We got about 10 minutes, so if you got something to show, Poncho, let's do it.
Can I say something real quick?
You need to present. Oh, is that it?
You don't.
Hold on.
I hear you say that you don't actually know how to prove the globe yourself, but you know somebody else does, it's been figured out. This is a place that all of us came to in our journey, where it's like they figured it out, right? Like Greeks, but ancient Greeks, scientists, somebody figured out for us.
So we can go to the beach and hang out. Don't have to worry about it.
Came to a point where we were like, I should know how to prove this. And as an incredibly prominent scientist that you are, I would say, maybe you should figure out how to prove it.
Can I say something to this? Because I think this is where it really comes down to, right? How many other things do you take for granted? Let's be honest right now. Think carefully before you answer, right? Because often I have heard answers right away that are false.
I'm not
okay, I know you don't believe that, and later on you're like, well, okay, no, I do. Don't trust them. But how often do you believe in stuff that others have told you that you take for granted and you haven't researched yourself?
But
I would say
many things.
I would say
I'm
most things.
not faulting you at all for not knowing.
What? After flat Earth, it ain't much anymore.
That's the thing.
No, but
I think
you
none of us
have to
know,
take
and
some
we have
things.
to realize we don't know.
You have to take some things for granted. Why? Think about this.
Until there's a reason to question.
Yes.
Until there's strong.
And what is your reason for questioning whether the Earth is flat or not?
Because we can see too far. We can see too far.
No.
And we have proven, I've seen with my own eyes proof that water is non-convex. Water is flat and level, and I've seen it with my own eyes.
let me ask you something. This is like one of the final questions for me, and I will listen to you. What if everyone else told you, and it was, you lived 500 years ago, or 600 years, whenever it was, and everyone said the Earth is flat, and the center of the universe is the Earth. And you're like,
I think
wait a minute,
wait
a minute, yeah, what if it is the other way around? And then you're starting, which is actually what happened in human history, right? And you start thinking like, and there was a big authority, it was Aristotle, who stunted everyone and said like, no, it's this way and all stuff. And then you start finding evidence, and then you keep accumulating evidence, and all of a sudden, all of human history and society says, you're right.
What? Well, we don't experience that though.
But
it started like a philosophy and then turned into like a mathematical thing. And none of that we actually experience and can prove. Still to this day, as far as I'm concerned. Now, I've loved astronomy for 35 years, and I consider the flat Earth something provable.
I will ask you this, right? Exactly. Sending to the ISS, because let me ask you something, right? Because in science, you do experiments to disprove yourself, not to improve your position, right? That's the key difference from religion, where you're trying to figure out evidence that supports your belief. Science is the opposite, right? That says, what experiments can I do, not to figure out like, oh my God, yes, I'm right, but like, what would I do that would be, oh wow, this is a counter, I only need one, I was wrong, let me figure out why now, right? How many times have any of you have done experiments without the precondition that you wanted to see the light from across, and that you wanted to immediately believe, oh, but that's because it's flat, not because there's something else going on, it's just flat. And
no, we know that the atmosphere plays absolutely the biggest role in all of that.
No, but all the other evidence would throw away everything else, right? All the other evidence. And how can you throw it away? Not because you've seen the evidence and you're like, oh, we did this. It's because there's a conspiracy. And let me ask you one last thing. How many of you believe in more than one conspiracy in this world? How many? Do you believe in anything else beyond the flat Earth? Any other conspiracy?
I try not to. I try to stay away from beliefs, because belief is the enemy of knowing.
Exactly.
And I prefer to know something and not believe in it, because believing in it is not really a knowing.
A lot of things that people call conspiracy, really a lot of evidence for. It's not a conspiracy; it's a fact.
All right.
Hey, Poncho, you ready?
Hello. Go ahead,
Hello.
Poncho, hit him.
Hello, Spiros.
Hi, Poncho.
Thank you for giving your time again. I've got questions and pictures from the chatters this week, not mine. So the first point that one of my listeners have pointed out is that the inertia between 12 o'clock and 12 a.m., 12 p.m. and 12 a.m. is 2,000 miles an hour. There is no peer-reviewed paper that shows I'm in motion. I've been looking for it for a long time. If you fire a 50 cal up in the air, it'll take exactly 1 minute, 50 seconds to come right back down where it landed. Boom.
Okay, what's the...
There's no Coriolis effect.
Wait.
It left the Earth. The Earth is traveling at 1,000 miles an hour, and all the other four equations that go into it.
There is a... Wait, do you know that the military, when they shoot like artillery over long distances, they have to correct for the movement of the Earth?
No, that's not true. Railgun.
See, they have. I have a PDF file document, 30 different documents from NASA, Navy, military, all government officials that all state that that all state that their calculations are done on a flat stationary Earth. There's no accounting for any kind of movement, no curvature, no nothing.
Wait, are you talking about curvature or about the movement of the Earth?
Both. For curvature, they don't account for curvature. They don't account for movement. Which, if we were spinning at,
where have you seen that? Because I can
shoot you the PDF.
I just went to Metabank that you sent me, and then
no, this is an actual published paper.
Personally, know a man who was in the military, and he manned tanks, and he shot the projectiles from the tanks for many, many miles, and he never accounted for Coriolis.
And the railgun debunks all of it because it can hit a target 100 miles away, Spiros.
Okay, can we do like this science thing? And actually, you try to show me YouTube videos. Let's do that, a quick one. A YouTube video of
Not
what I just
tonight,
said.
but we can do it.
Yeah.
You gotta go. You gotta go in like 2 minutes.
I know. I have to go.
Poncho,
Very soon.
hold on. Let Poncho finish.
Yes.
Poncho.
Okay. So the railgun debunks everything you just said because it'll hit a target 100 miles away in a straight line. No adjustment for the artillery of the shell. The line of sight of a radar microwave is 146 miles, impossible on a ball earth. If you was to use this is a test that we should do, Karen, a laser audio device at a window 10 miles away, there's no way it could happen on a ball earth.
Well, actually, the next test that FE Core is doing is a microwave test at over 215 kilometers. So,
okay. But the sound one's a pretty good idea as well. The heliograph mirrors and signals 156 miles, 1898. Light slows down when passing through glass, Spiros, and then accelerates again. I see Venus, Mercury most of the night from the backside of the Earth when they're in the wrong lanes.
And also light slowing down and when going through glass and then speeding up through after it leaves the glass defies the law of the conservation of energy, defies a basic law of physics.
Not at all, no. It is just exactly how it's supposed to work, right? Because light can interact with matter, specifically the electrons within atoms, and what happens is it is absorbed and re-emitted. This is exactly how we even see anything.
Do you believe that photons are real?
Yes.
Okay, then let me ask you a question. Do you have a camera that you take pictures with?
What was that? Sorry?
Do you have a camera that you take pictures with?
Yes.
Do you ever have to empty the photons out of your camera after you're done using it?
No, this is not how photons work. Photons don't have any mass.
Photonic buildup.
Right. They don't have any mass, so how can they exist? How does something exist when it doesn't have any mass? There's no empirical evidence for a photon.
Very good question. Because it asks the following deep question: what is mass? Right? And this is a very beautiful question, which has to do with something very deep from general relativity. Right? There's actually only one answer.
This is where we get into VR.
The board. And it is our intuition that mass is supposed to be something that, right, you see and it can impact you and it can give energy. You don't require that. Energy, right, can have the same impact as mass. It's something which has equivalent mass equals mc squared, right? So photons actually don't have any mass and they travel at the speed of light as expected, because the definition of mass is a difference between energy and momentum of an object. And the one object in the world that has equality between its energy and its momentum is, you guessed it right, it's light. Everything else has a mismatch. And that mismatch is exactly what we call mass, right? Where it forms also like atoms and...
We're going to have a third session.
I know.
And that's just
a lot of cool stuff.
I have one last remark for Spiros, if that's okay.
Yes.
Before we go, Spiros, you're a very good sport for joining us. I just want to say that, I think you're a really good sport for joining us, and you're actually kind of handsome too. But, you live in South Carolina or in California, right, on the coast?
Yes.
So I'm sure you watch the sunset from the beach every now and then. Okay, when you stand there on the beach and you watch the sunset, you believe that you are falling backwards faster than the speed of sound. As you fall away from the sun. And you should really think about that the next time that you watch the sunset on the beach.
I'm not worried about that. The problem is that if the Earth was accelerating at any point as it was rotating, that would be an issue.
Well,
but if it is just rotating at a constant angular momentum, you would never know.
If you try,
but you should know.
You would know.
We gotta go.
Well, you don't have a frictionless environment because you can't really prove that you can have a separation from a pressurized environment to a vacuum environment. So you're going to have some friction. So an elliptical orbit is going to encounter some differences in speed.
So just to make it clear, imagine that you put something on a spinning ball, right? And then you have enough force to get it stuck on the ball. That's gravity, for me at least, right? And you're spinning it faster and faster. You need to spin very, very, very fast before it starts ejecting, right? Before first all the pressure, from the air that we live in and all stuff. And it is so fast that you're woo, you're flying out into space that'd be really cool, but probably you don't want to go into that. But yes, maybe.
Well, we wouldn't live very long.
So, Spiros, real quick, I just emailed you all those documents from NASA.
30 of them.
Yeah. NASA.
Nathan, can you email him the link to FE Core so he can look at the document for the experiments too?
I mean, just to quote one, the method is limited, however, to an application where a flat, non-rotating Earth may be assumed. Nonlinear equations of motion used in the model are general 6-degree of freedom equations representing the flight dynamics of a rigid aircraft flying over a stationary atmosphere over a flat, non-rotating. That's two quotes from two different articles.
But that's for aircraft, not for artillery. I'm talking about.
No.
But as I said,
I know. There is.
That's an aircraft thing.
There's all these things. I emailed this to. I emailed this to you. But I just want to close with a little quote from Carl Sagan. I mean, you like Carl Sagan.
Yes.
So you like Carl Sagan?
you like Carl Sagan?
Sure. I used to love it.
That's great. You used to love him.
I mean, there's a small bit of truth in everything. So
you're not biased, are you?
This is from Carl Sagan. One of the saddest lessons of history is this: if we've been bamboozled long enough, we tend to reject any evidence of the bamboozle. We're no longer interested in finding out the truth. The bamboozle has captured us. It simply is too painful to acknowledge, even to ourselves, that we've been taken. Once you give a charlatan power over you, you almost never get it back.
That's is this actually from Carl Sagan?
Yeah, it is.
What was he talking about?
He was probably talking about religion. More
okay.
But it doesn't matter. I mean,
it does matter. I'll tell you why it matters. I will tell you why it matters. Because the idea that the Earth is a globe
is a religion.
No.
Yes, it is. It's a belief.
No,
it's a belief.
Not a belief. It has been
100% a belief.
By a trillion number, but that's not my point.
You don't know how to prove it.
That's not my point. No, it's like. Let me put it this way.
It's going to help us prove.
What was, and I'm down to
it's down, it's down.
Well, either way, whatever we see, right? So,
we got this.
They've been 30,000 years that people thought the Earth was flat. Do we agree?
Agree.
Right? Until 400 years ago. Until 400 years ago or so, whatever it was. And then all of a sudden they were like, all right, wait, what if, no? And all the evidence since then has mounted towards which direction? The one that used to be the truth back then, or a different truth now? So I'll just leave you with that.
All the people that brought that evidence are related to the royal family.
I mean,
no, they're not. Please don't go.
They're all Jesuits.
I told you that if we are willing to give each other the benefit of the doubt and to see the best in others, we have to do it with people that we don't even know, right? Because if you want other people, I don't understand the other community. It's not crazy or it's not a bunch of conspiracy theories and all that stuff. If you want them to give you that benefit of the doubt, you need to be able to do that for them as well, even if it is a small group of people.
I agree.
Right?
Spiros, man.
Can I have a go? Let me finish.
Yeah.
Parting comments. Who's got
All right, quick one.
Go.
Quickly, okay, presenting. Okay, so the curvature chart is 24 feet at 6 miles. I went to my local beach, laid on the beach, Spiros.
Yes.
Filmed straight across.
Yes.
And I shouldn't be able to see the other beach, but I do. At 6 miles, it should be 24 feet of curvature.
Let me ask you something. Do these look like whatever you were looking at, right? These massive windmills. Do they look like they've been chopped off and they're all...
No. It wasn't the windmills that I was zooming in at. It was the lighthouse look.
I would go back to the windmills. Do they look a little short for you?
They're further back. I'm looking at the 6 miles to the lighthouse there. I'm looking at that.
I'm with you. Does the lighthouse look a little bit short?
No, it's because it's stood upright. It's because I can see the beach at the bottom. Look, that's what's.
But you know, when you're looking at things long distance, though, the horizontal planes seem to. It's like when you're in art class and you're trying to draw something with perspective. You have a line in the center, and then everything converges to that perspective, that vanishing point in the center.
The field of vision
to rise up, and the sky plane seems to go down. It's like when you're looking long distance and the clouds look like they go to the horizon, you know that the clouds are not actually sitting on the horizon. They just appear to be on the horizon because everything seems to converge at that vanishing point.
Just like the telegraph poles here.
It's the angular resolution and horizontal planes.
Yeah, the sky's not touching the ocean.
Disappear from the bottom
and the
up.
same goes when you're looking up.
It's not. That's not what I'm talking about. I'm not talking that the relative size looks smaller. It seems that the bottom of it is just chopped off exactly as it should be if it was curved. Not that you're seeing.
No, not exactly as it should be, though, because we have plenty of observations that don't match the size of the given size of the globe Earth. It is a finite size. They have numbers for it, and what we see do not match the measurements for the globe Earth.
I just saw
we consistently beat that.
From Poncho's camera. I believe Poncho. I just saw that the wind.
The eyeball shows that you can't see that far, Spiros. You have a field of vision.
The world's a much, much bigger ball.
To the vanishing point.
But we're seeing too far. So if you want to say there's still a curve,
I am telling you that it is definitely curved, but it has to be. It is a very large ball. And we're tiny relative to the curvature.
But to match the observations that we make, we would have to be living on a ball bigger than the size of Jupiter.
Yeah, look at the size of this thing. Look.
Which size?
It's flat as a pancake at 130,000 feet. It's flat.
I love you guys. All right, we'll have to. Yeah, sorry, I have to go for dinner. We'll have to continue. Maybe in a couple of weeks or so.
That would be fantastic.
Wow. Spiros, they're 120 miles apart. These two cities are 120 miles apart. No curvature.
This is
X-axis.
I am amazed and impressed.
No X-axis.
We'll have to leave it for another time.
I don't believe that light bends. Neither does water. Nobody bends water.
Okay.
All right.
If we're gonna end this, we're gonna have to meet Poncho. He's not gonna do it himself.
Next time we get together, I'll have to show you the
experiment
that we did.
Yeah. Cool.
It was a 6 mile experiment.
We got a couple weeks.
That's great.
Beverly Hills is waiting for me.
Maybe I'll do another one before next time.
Okay.
Maybe we'll try like
and
this
I want to do one with you guys.
We're gonna do one. At least one.
Can we build an atmosphere like the card and go up there?
Spiros, will you do a one-on-one with me? Just me and you.
No, Spiros, how about